Hey everyone, ready for another deep dive? Today we're tackling something pretty cutting edge in cancer treatment. Dual PD-1 slash PD-L2 blockade. It's like we're taking immunotherapy to a whole new level.
Yeah, it's really exciting stuff. We're basically supercharging the immune system to fight cancer even more effectively.
Now before we get ahead of ourselves, maybe we should back up a bit. For anyone who's not quite up to speed on the whole immunotherapy thing.
Right, good point. So basically, our immune system is amazing. It can recognize and destroy all sorts of threats like viruses and bacteria, but it also needs a way to control itself to make sure it doesn't attack our own healthy cells.
Okay, that makes sense. It's kind of like checks and balances for the immune system.
Exactly. And those checks and balances are what we call immune checkpoints. They're like brakes on the immune system, preventing it from going into overdrive and causing damage.
So I'm guessing this is where cancer cells come in and mess things up.
You got it. Cancer cells are sneaky. They've figured out how to exploit these immune checkpoints to hide from the immune system.
So they're basically hitting the brakes on the immune response, preventing those powerful T cells from attacking them.
Precisely. And one of the main ways they do this is through a molecule called PD-1 and its partners PD-L1 and PD-L2.
Okay, so we've got our Assay Genie article here. Dual PD-1 PD-L2 blockade, expanding the horizons of cancer immunotherapy. They break this down really well. So can you kind of walk us through how these molecules work?
Sure thing. So picture PD-1 as an off switch on the surface of T cells. Those T cells are like the warriors of our immune system, patrolling the body and looking for anything suspicious.
Okay, I'm with you so far.
Now, PD-L1 and PD-L2 are like the keys that fit into that off switch. When they bind to PD-1, they essentially shut down the T cell.
Oh, wow. So the cancer cells are basically waving these off-switch keys around, tricking the T cells into thinking everything's fine.
Exactly. They're like, hey, nothing to see here, move along.
Sneaky little devils.
I know, right? And the result is that the T cells become inactive. They can't effectively attack the cancer cells.
So it's like the cancer cells are creating their own invisibility cloak, hiding from the immune system's radar.
That's a great way to put it. And that's why immunotherapy has been such a game changer.
Because it's like we're finally figuring out how to rip off that invisibility cloak.
Precisely. And that's where dual PD-1, PD-L2 blockade comes in.
Okay, I'm all ears. Tell me more.
Well, as you might guess from the name, it's all about blocking both PD-1 and PD-L2 at the same time.
So instead of just targeting one of those off-switch keys, we're going after both.
Exactly. We're cutting off both escape routes for the cancer cells, making it much harder for them to evade the immune system.
This is starting to sound pretty powerful. So how exactly are we achieving this dual blockade?
Well, the article highlights a really promising monoclonal antibody called TY25. It's designed to bind to both PD-1 and PD-L2, preventing them from interacting.
So it's like TY25 is this double-sided sticky note glomming onto those keys and keeping them from turning off the T cells.
I love that analogy. That's exactly what's happening.
Yeah, this is so cool. So what kind of effects does this have on the immune response?
Well, for starters, it reactivates those exhausted T cells, giving them a much-needed boost so they can start fighting again.
So it's like we're waking up those sleepy warriors.
Exactly. And not only that, but it also helps new T cells infiltrate the tumor,
Yeah.
basically bringing in reinforcements to join the battle.
This is amazing. It sounds like we're tipping the scales back in favor of the immune system.
You got it. We're shifting the balance from immune suppression to immune activation.
I'm already starting to see why this is such a big deal, but I'm curious, there's something in the article that really caught my eye. This whole idea of focusing on PD-L2.
Oh yeah, that's a key point.
Can you explain why that's so important?
Sure, so PD-L1 is kind of a common signal. It's expressed on a lot of different cells throughout the body. But PD-L2 is a bit more exclusive. It's mainly found on certain immune cells and specific types of cancer cells.
So by targeting PD-L2, we're kind of honing in on those cancers where it plays a particularly big role.
Precisely. And this is where dual blockade really shines.
Because we're hitting both PD-L1 and PD-L2, we're basically taking away the cancer's backup plan.
Exactly. It can't just switch from one key to the other to evade the immune system.
Wow, that's brilliant.
And the potential benefits are huge, especially for cancers that haven't responded to other treatments.
Okay, so I'm definitely sensing a but coming here. What's the catch?
Well, as with any powerful therapy, there are potential risks and challenges. One concern with immunotherapy in general is the risk of what we call immune-related adverse events, or IRAEs.
Right, because we are essentially revving up the immune system. So there's a chance it could go a bit overboard and attack healthy tissues.
Exactly. And since dual blockade involves targeting two checkpoints instead of one, There's a possibility that the risk of IRAEs could be higher.
So it's like we're playing with fire a little bit.
In a way, yes. But the good news is that these side effects are usually manageable with medication and close monitoring.
So it sounds like finding the right patients for this therapy is key.
Absolutely. Careful patient selection and close monitoring are crucial.
Okay, so we've got this incredible new approach, but we need to be very careful at who we use it on.
Precisely. And as we learn more about these therapies, we're getting better at identifying biomarkers that can help us predict which patients will benefit the most.
That's really encouraging. So dual PD-1, PD-L2 blockade is clearly a promising approach with the potential to revolutionize how we treat cancer. But the story doesn't end there, right? We've only just begun to explore this exciting new frontier.
Oh, absolutely. There's so much more to uncover, and that's what we'll be diving into in the next part of our deep dive.
Can't wait. I'm already hooked. Okay, so we left off talking about how TY25 is like this double-sided sticky note, glomming onto both PD-1 and PD-L2 and keeping them from shutting down the T cells. But it's not the only game in town, right?
All right, there are other dual blockade therapies in development as well. It's a really hot area of research.
Yeah, that makes sense. So much potential to unlock. But before we move on to those, can we delve a little deeper into how TY25 is actually working within the tumor?
Sure. So you have to understand that the tumor microenvironment is incredibly complex. It's not just about the cancer cells themselves.
Right, there's a whole ecosystem in there.
Exactly. And this ecosystem is full of cells and molecules that can suppress the immune response.
So it's like the cancer cells are building their own little fortress to protect themselves from the immune system.
That's a great way to put it. And PD-L1 and PD-L2 are key components of that fortress.
Ah, so they're not just waving those off switch keys around, they're actually building a whole wall to keep the immune system out.
Exactly. And TY25 comes in and breaks down those walls.
Okay, so I'm picturing TY25 like a wrecking ball now.
Yeah, I like that.
The article also mentioned something about myeloid-derived suppressor cells and regulatory T cells. What are those all about?
Ah, yes, those are the double agents.
Double agents?
Yeah, they're actually part of the immune system, but they get tricked by the cancer cells into working against us.
Oh, wow. So they're like the guards protecting the cancer cell's fortress?
Precisely. They help keep the immune response suppressed. But TY25 can neutralize those double agents as well.
This is getting better and better. So it's like TY25 is not only breaking down the walls, but it's also turning the guards against the enemy.
I love that analogy.
So with all these mechanisms in play, it sounds like TY25 could be really effective against a wide range of cancers.
Well, it definitely shows promise. But remember, PD-L2 expression varies between different types of cancer.
Oh, yeah, right. So it's not a one-size-fits-all solution.
Not exactly.
Yeah.
There are certain cancers where TY25 seems particularly effective. The article specifically mentioned non-small cell lung cancer, head and neck cancer, and Hodgkin lymphoma.
Okay, let's dive into those a bit. Starting with non-small cell lung cancer. What makes TY25 so promising for this type of cancer?
Well, it's the most common type of lung cancer, and it's often diagnosed at a late stage, which makes it harder to treat. Plus, it's known for expressing both PD-L1 and PD-L2.
So it's like this cancer has built an extra thick wall around itself.
Exactly. But TY25, with its double blocking ability, can break through that wall.
Okay, that makes sense. What about head and neck cancer?
Well, similar story there. Head and neck cancers often rely heavily on PD-L2 for immune evasion.
So again, TY25 could be a real game changer for these patients.
That's the hope. Early clinical trials are showing promising results.
Very encouraging. And lastly, what about Hodgkin lymphoma?
So Hodgkin lymphoma involves these unique cells called Reed-Sternberg cells. And guess what? They express high levels of both PD-L1 and PD-L2.
Ah, so they're really dependent on those off switches to survive.
Exactly. And that makes them a prime target for TY25.
It's amazing how scientists are figuring out all these intricate details of the immune system.
I know, it's incredible. And we're just scratching the surface.
Speaking of scratching the surface, we talked a lot about TY25, but there are other dual blockade therapies out there too.
Oh, absolutely. There's a whole pipeline of new therapies in development.
Well, what makes them different from TY25?
Well, some are designed to be even more potent, like they bind to PD-1 and PD-L2 with even higher affinity.
So it's like we're upgrading from a regular sticky note to industrial strength glue.
Uh-huh. Yeah, something like that. And then there are therapies that are engineered to target specific subtypes of PD-L2.
Subtypes?
Yeah. Remember how we talked about PD-L2 being more exclusive than PD-L1? Well, it turns out there are different variations of PD-L2.
Oh, wow. So it's getting even more specific.
Exactly. And some of these new therapies are designed to home in on those specific variations.
So it's like using a laser-guided missile instead of a shotgun approach.
Precisely. And that could potentially lead to fewer side effects and even better outcomes.
It's all so fascinating. It feels like we're on the verge of a whole new era of personalized cancer treatment.
I agree. It's an incredibly exciting time to be in this field.
Okay, but before we get too carried away, I want to circle back to something we touched on earlier. The potential downsides of manipulating the immune system.
Right, of course.
We talked about the risk of IRAEs. But are there other long-term consequences we should be thinking about?
Well, that's a question that scientists are actively investigating. One concern is that by constantly stimulating the immune system, we might be increasing the risk of autoimmune diseases down the line.
So it's like we're pushing the immune system into overdrive, and there could be unforeseen consequences.
That's one possibility.
Yeah.
We're still learning about the long-term effects of these therapies.
It sounds like there's still a lot we don't know.
That's true, but the potential benefits of immunotherapy are simply too great to ignore. We have a real chance to make a huge difference in the lives of cancer patients.
Absolutely. It's a delicate balance, but the rewards are potentially life-changing.
Exactly.
Well, this has been an incredible journey so far, but we're not done yet. We've got one final part of our deep dive to go, where we'll explore some even bigger questions about the future of dual PD-1 PD-L2 blockade and the implications of manipulating the immune system.
I'm looking forward to it.
Okay, so we've covered a ton of ground on this deep dive. We've talked about how dual PD-1/PD-L2 blockade works, the potential benefits, the challenges. But now I kind of want to zoom out a bit, look at the bigger picture.
Yeah, that's important. We need to think about the implications of all this.
Right, because we're not just talking about a new drug here. We're talking about manipulating the immune system, which is like messing with the very foundation of our health.
Exactly. And it's powerful stuff. I mean, we're basically repurposing a system that evolved to fight infections and using it to fight cancer.
And that's both amazing and kind of scary at the same time, right?
Yeah, definitely. Because there's always a risk of unintended consequences.
Right, like we talked about those immune checkpoints, how they're like brakes on the immune system.
And those brakes are there for a reason, to prevent the immune system from attacking our own bodies.
Which is what happens in autoimmune diseases.
Exactly. So when we develop therapies that release those brakes, we have to be extremely careful.
It's like we're walking a tightrope, trying to find that sweet spot where we boost the immune system enough to kill cancer, but not so much that it starts attacking healthy tissues.
That's a great analogy. And that's why research into biomarkers is so important. If we can identify those patients who are most likely to benefit from immunotherapy and least likely to experience those severe side effects, then we can really make these treatments safer and more effective.
That makes sense. So looking ahead, where do you see this field going in the next 5 to 10 years?
Oh, wow. Well, I think we're going to see a ton of new immunotherapies targeting all sorts of different immune checkpoints. We're going to be able to fine-tune the immune response in ways we never thought possible.
And I bet technology will play a huge role in all this.
Absolutely. Things like gene editing and personalized vaccines are already starting to make a big impact.
Yeah, we talked about those personalized vaccines earlier. Imagine getting a vaccine that's specifically designed to attack your unique tumor.
Right. It's like having a secret weapon custom made for your body.
It's mind-blowing.
And when you combine those personalized vaccines with dual PD-1/PD-L2 blockade, you're creating this incredibly powerful force against cancer. We might even see a day when cancer becomes a chronic manageable disease, like diabetes or heart disease.
Wow, that would be incredible. But okay, before we get too carried away with all the optimism, I want to come back to something we've touched on a few times, the potential downsides of manipulating the immune system.
Right. Of course, we can't just ignore those.
So what are some of the long-term consequences we should be thinking about?
Well, one concern is that we might be inadvertently increasing the risk of autoimmune diseases.
Yeah.
By constantly stimulating the immune system.
So it's like we're pushing the immune system into overdrive. And that could have some unintended consequences down the line.
Exactly. We're still learning about the long-term effects of these therapies, and we need to proceed with caution.
Yeah, it's a delicate balance for sure. We want to push the boundaries of science, but we also need to respect the incredible complexity of the human body.
I completely agree.
Well, I think that's a great place to wrap up our deep dive. We've covered a lot of ground today. From the intricate mechanisms of dual PD-1/PD-L2 blockade To the potential benefits and risks of manipulating the immune system, it's clear that this is a really exciting field with so much potential. But it's also a field that demands careful consideration and ongoing research.
Absolutely.
So thanks again for joining us on this journey. We'll be back next week with another deep dive into the world of cutting-edge science and technology. Until then, stay curious.